right, so today we are diving into 12.1, which is all about, this whole next chapter is on, actually the next couple of chapters are all on 2- and 3-dimensional shapes. So we start off easier, we start dealing with 2-dimensional shapes, and then we get into 3-dimensional figures, and then we do surface area and volume for those 3-dimensional figures. A lot of fun stuff because geometry is awesome. It's all around you. Literally, it's all around you. So, general note, if you are still not done with your mastery, try to get that done in AOR extensions today. I did not grade them over the weekend because I knew that people needed to work on them. So if you are not done with the circles mastery, please try to get it done today in AOR extensions so I can grade them tonight while my wife is at yoga. She's like, I have yoga. I'm like, sweet, I'll grade tests. So when you think about 2-dimensional shapes, all right, I guess we'll watch the intro video. We'll let you guys have it.
In this topic, we'll be investigating shapes, specifically a number of 2- and 3-dimensional shapes. For instance, we will ask the question, what information do you need to draw a unique triangle? We'll also do a little slicing and dicing and learn how the faces of a rectangular prism or pyramid can determine the shape and dimensions of a slice of that prism or pyramid. Finally, we'll see why it may be important to have precise descriptions for drawing or making figures. All that and more is just ahead, so let's get this topic started.
Notice one of the first things that your notes says, you'll need a ruler and a protractor. So even if you share them, because we may not have totally enough for everyone, but you're going to need a ruler and a protractor today. Hey guys, quit smacking my rulers. That's how they break. That's why most of them are broken. You do not need 12 inches of the ruler. You just need a straight edge. So if it's a part of the ruler, it's okay. You can just take the tape to your desk if you need. When you've been asked to draw shapes in the past, what do you normally know, or what are you told, or how do you know how to draw a shape? Well, what do you know? Like, what did you learn about shapes? What
How to draw circles. We just kind of learned them.
Okay, so what's a characteristic of pretty much all 2-dimensional shapes that we work with?
They have sides.
What about the sides? Straight, right? All the shapes that we tend to work with, most of the time, has straight sides unless it's a circle. And then it's one continuous circle, obviously. What else? To make a shape, like if I draw, is that a shape?
No, it's not complete.
Oh, it needs to be closed.
Ah, so my 2-dimensional shapes have to be closed. That means that at every time 2 sides meet,
It has to be at least 3 sides though.
has to be at least 3 sides because the triangle is the least amount of sides that we can use to make a shape. At every corner, there's going to be certain angle measures, right? And depending on the shape, depends on what those angle measures are going to be. What are some specific rules about angle measures that relate to certain shapes?
All the angles in a triangle add up to 180 degrees.
Yeah, the sum of a triangle's interior angles must be 180 degrees when you total it up.
No matter how hard you pull that.
Or else it's not actually a triangle. What other angle rules do we know? There should be one other that at least comes to mind easily. Thomas?
All quadrilaterals have to equal 360 degrees.
Yeah, all quadrilaterals have to equal 360, but more than that, because we have that rule for every shape as we go. What about squares and rectangles?
Right angles.
Ah, we have to use right angles. My squares and rectangles have to use right angles. So guys, if you come in late, I know it's not your fault, but grab notes from where you know the notes are kept. Make sure you get your homework written down and catch up with us. So, yeah, let's look at this really fast. It's worth it, especially since you guys just came in.
Hello, I would like you to make a sign for me, but it's an unusual shape.
Unusual?
Yes, it has to be an 8-sided sign. Can you make one?
I can make that. Hang on.
So, think in your head right now, when you think 8-sided shape, what would it look like?
What's that?
An 8-sided sign. You said it was an unusual shape.
So, is this an 8-sided shape?
Yes, technically.
Yeah. I've got 1, 2, 3, 4, 5, 6, 7, 8 sides. But it's not an octagon, right? Or it's not an octagon like you think about.
It's not a regular octagon, but it is an octagon.
Because what about a regular octagon? What does regular mean?
It has all equal sides. It has all equal angles on the inside.
Both of what you just said has all equal sides and all equal angles. So this is an octagon. It's an 8-sided shape, but it's not a regular octagon. A regular octagon would all have the same side lengths and the same angle measures on the inside, which also then we can look at exterior angles, and those would do the same thing as well. So when we talk about drawing a quadrilateral,
You can draw a geometry.
so if I ask you to draw a quadrilateral with exactly one pair of perpendicular sides, now what does it mean to be perpendicular?
That can cross.
Yeah, so big important vocab. If you can't remember this, here's your 2 examples. For A, perpendicular. Might as well just pull it up. I would off to the side here, beside perpendicular, draw an example of perpendicular lines. Or you could just draw 2 and then draw the right angle. Something to remind you that perpendicular, make a right angle. Now, the notation for parallel sides is a little bit different because we can't just draw 2 lines. For things to be parallel, they're not there yet. They'll be there at the end of the day, so they're still, whatever you want to call that. I show that 2 sides are parallel by drawing the 2 sides, and then I put an arrow on each of the lines pointing the same direction. What that arrow tells me is these lines can go on forever and never touch. So then try to draw a quadrilateral for each of those. You want exactly 1 pair of perpendicular sides and then 2 pairs of parallel sides, but no right angles. Ooh, no right angles. That's going to make it a little difficult. Exactly 1 pair of perpendicular sides. For A, we have a lot of options actually. I start with my perpendicular sides. Then you really have many, many choices here. I'm going to make this skew off, can't be perpendicular. I'm going to make that so it can't be perpendicular. This could look a lot of different ways. All that it matters is that you have 4 sides. They're all connected to each other. It has to be a closed shape. And you have 1 perpendicular corner. Now, 2 pairs of parallel sides, but no right angles. I don't know what kind of shape this is. So I've heard rhombus and I've heard trapezoid. Can't be a rectangle because no right angles. Ah, so a trapezoid, to reference back to it, something that looks like that, where we have 1 pair of parallel sides. But that's not what I want. Hold on, if you're drawing this, that's not what I want. That would only have 1 pair of parallel sides. I need 2 pairs of parallel sides. So I'm going to start my top and my bottom. I'm going to notate that they're parallel. But then I need 2 more parallels. Crystal? Excuse me? A hexagon? Yeah, we need only 2. So actually, we've been told make a quadrilateral. Yeah. So that's, we could, I know what you're thinking, that would have, but since, well, it doesn't say exactly. So a hexagon, if it's a regular hexagon, will have 3 pairs of parallel sides. Since this one's 2. Now, if I draw vertically, can't, because that's going to make a rectangle. So instead of drawing vertically, I'll draw add an angle and then match that angle and notate these are parallel with each other. And then I can get rid of all the extra beyond where they connect. So I can erase that. I can erase that extra. I can erase this extra. And I can erase that extra. We get a rhombus. So go ahead and label this RHOMBUS. It's a rhombus. So this goes back to where broader definitions encompass other shapes. Rhombus includes rectangles. It includes squares. So every square is a rhombus. Every rhombus is not necessarily a square. So every square is a rhombus. Every rhombus is not necessarily a square. So now, and we talked about this already very quickly, for the got it, sketch a quadrilateral that only has one pair of parallel sides. Sketch your quadrilateral that has one pair of parallel sides. We brought this up really quickly, but Laylee, do you remember what kind of shape that's going to give me? A trapezoid. So normally when we're asked for one pair of parallel sides, we do that on top and bottom. It's just a little bit easier. My arrows, they're slightly, notice because my smartboard's getting a little glitchy, they're slightly high, but as long as we can kind of show that, that means that they're parallel. And then my other two sides, really my angles on those could be at any type of angle. I could also draw a trapezoid like that. Is that still a trapezoid?
Yeah.
It still has one pair of parallel sides. Now it's a trapezoid that also has a perpendicular side, but it doesn't matter. It does not have two pairs of parallel sides. So I would, once you have this drawn, write down trapezoid to help you remember that. And this is easier for me to remember because like in Kashaktan we have to deal with animals and things like that. But if you've ever seen a live animal trap, it's like a box, but then inside of the box there's like doors that come down that like lift up and will trap the animal. So if you think about a live trapezoid, you're trapping something in there. So I don't know, that helped me remember trapezoid. Yeah.
Yeah, there's like one of those weird guys that looks just like a trapezoid.
Mousetrap?
Yeah, that guy.
That's so hard to say.
That's a classic.
Yeah.
So now, hopefully you guys all have your rulers and your protractors. If you do not, try to grab one, or you can share with a partner. Check what this. We did all that. So
To draw a
we now want
parallelogram,
to
begin by drawing one of its sides.
use our ruler. We want to draw a parallelogram. What's it mean to be a parallelogram? Luke? So is a rhombus a parallelogram?
Yeah.
Yeah, right? So, parallelogram, 2 3-inch sides, 2 4-inch sides, 2 60-degree angles, and 2 120-degree angles. This has literally told me all of the details. I know everything about my shape. So we're going to do on our paper right now, and I think you have space to do 4 inches and 3 inches. I didn't check with my notes. The question is if the angle will fit. So I think this will fit if you do this carefully and trust 4 inches. Yeah, it should. So on your notes, this will only fit if you do it correctly. On your notes, start way down here. Do your 4 inches across here, and then your 60-degree angle is going to be right in here. So that's how you want to start. You're going to do your 4 inches on the bottom. Your 60-degree angle is going to be right in that bottom corner. So once I have my 4-inch side, I stick my protractor on that vertex or on that end point. And remember, how do I know what set of numbers to use? Like here in what I have up on the board, am I going to use the inner set of numbers or the outer set of numbers? Why, Isaiah?
Because the 0 is
Yeah, I look for where my line crosses through the 0. That 0 is in the inner set. So now I'm going to come up to my 60 degrees right here. And I'm going to draw a line from my end point of my line through my 60 degrees.
And that should be 3
And I'm going to label that 60 degrees correct. And then I want to use my ruler to make sure that that's only 3 inches long. So find out where that 3 inches ends and erase any of the extra line that you drew. So you're going to set your angle, draw your line. And when I first draw my line, I don't care how long it is. I actually almost like it to be longer than 3 inches. It makes my life easier.
makes everyone
Do we make the angle 3 inches?
The angle 3 inches. The edge will be 3 inches. So this line will be 3 inches long. The angle is 60 degrees. So here's where the tricky part comes in and where some people will run into mistakes. I've drawn that. I draw that side. Once I draw these two sides, how do I move forward? It keeps jumping. How do I then move forward? I've only got two sides drawn. I've got a few techniques. You don't have enough? It might, yeah, you might end up drawing on top of something else. It's okay. Yeah, if you draw on top. Or you can label it as 3 inches, but make it something shorter. Sorry. Right? Yeah, we'll switch back and forth. We have to teach you guys both because in America we use both systems. I wish we would go just metric. So from there, if this base angle is 60 degrees, can the other base angle be 60 degrees also? No. So that base angle will be its supplement. It will be what's left over to make it 180. So how big will this angle be? 120. So I move my protractor over to the other vertex. Put your point in the very middle. Then again, check your 0. My 0 is now on the outer numbers. But now I'm going to go up to 120 and put my line right through there, which if you notice, it's the same tick mark as 60, but now I'm just coming from the other direction. I didn't start down here. I started over on the left side, and that's why we open up 120 degrees. Yeah, that one will also be 3 inches. And then once you've labeled the top of that, like once you figure out where your side ends, you just connect. Last thing to do is just connect. The top of the one line to the top of the other line.
Yeah.
And then we can fill in everything else that we know. Draw the arrows for your perpendicular lines. Notice that if you don't have colors to change, I can change colors. Why do you think they use 2 arrows here instead of 1? Yeah, this line is not parallel to this line. That doesn't make any sense. So my single arrows are parallel to each other. My double arrows are parallel to each other. So then if I have a third set of parallel lines, I would use 3 arrows. A fourth set, I can use 4. Or we start changing the shape. Instead of using an arrow, I might use like a box or something, or an arrow with a box. Or sometimes people use an arrow with a line to be like that's the first one, or an arrow with 2 lines or 3 lines, something like that, just to denote that it's different. Any other questions about when it gives me the details? How to determine that? If I had started by drawing my bottom side and at this vertex done 120 degrees instead of the 60, my shape would then just look like this. it would just lean the other direction. If I started with 120 and
Wait.
Hmm?
Mirror image.
yeah, it'd be like a mirror almost.
If you think about it in depth, that looks like an open book.
Oh yeah.
Down 10.
All right, so try this. Use a ruler and a protractor to sketch the figure. If the figure is not possible, explain why. So we want a rectangle with 2 4-inch and 2 2-inch sides. So by it telling you that it's a rectangle tells you more of the details. What details does that tell us by being a rectangle? The angles. I know the angles because it's a rectangle. Now you can switch your scale. Sorry, if you want to, especially because how much room is on your paper there? You can cross these out and label it whatever you want. So if you want to do 4 centimeters and 2 centimeters, you can. Yeah, it'll be smaller, but we could do 4 centimeters and 2 centimeters.
That's what I'm doing. I'm doing 2 inches and 1 inch.
Yeah, however you change it. All that matters is that you end up with all 4 sides labeled, and what should be in every angle. Every vertex should have a little box to show that it's 90 degrees. So your labeling on your edges might be different, but you should get something like this. I'm going to capture what it wants first and then capture our solution. Hello.
Where is the cuff? Ooh. Hour of work.
There we go. Questions? If you get your rectangle done, try to move on to your next one. A triangle with 2 100 degree angles.
I love drawing shapes now. It brings me back.
So if we start drawing this triangle, I always start, it's easiest to draw your bottom side first. So I start by drawing my bottom side. I drag my protractor to the very edge. I find my 0 is here, so I'm going to open up 100 degrees. So I'm going to come to there. This is 100. Now I move my protractor, not rotate. This is the problem with a smart board. Moving my protractor, get that square again. Now I have to go the other way because now my 0's here. Open up 100 degrees. So here we have it. A triangle with 2 100 degree angles. It's got 3 sides. All my sides are straight.
But they don't connect.
It's not closed. So, you want to label this not possible. And you want to say why. And there's multiple reasons.
It has an opening.
So what everyone said is it's not closed.
Triangle has to be 180.
It does not sum to 180. And because of either of those reasons, not a triangle. Triangles are very tricky. We're going to look at some more triangle stuff tomorrow on when I give you certain conditions. Can it be a triangle or not? So what if we have a figure with 2 sides that are 1 inch, 2 sides that are 3 inches, and at least 1 right angle? Anyone think of what we would get when you're told 2 sides of 1 inch, 2 sides of 3 inches, at least one right angle? What comes to mind?
Square. Not rectangle.
Ooh, rectangle comes to mind, right? Can't be square. But think about it like this. It doesn't have to be a rectangle. They didn't say anything about parallel sides. All they said was one right angle. So I could make it. Anyone know what the shape on the right is?
Kite.
Ooh, it's not a rhombus, it's a kite. And one of the cool things about a kite, if you want to draw this example on your paper, I would, because this is a really cool shape we work with. These lines, I can't draw them very well, but those lines end up perpendicular. The lines that connect your diagonal points. It does look like an old school coffin.
I
Yeah,
actually have a stained glass.
like a Dracula sort of.
I have a stained glass little cake.
Nice.
Does it have to be to scale? Like,
No, you do not have to draw it to scale, but just label it. You might be able to draw it to scale. You could maybe fit that on there.
I can fit it.
So although a rectangle is the first thing that pops into your mind, don't get yourself fixated on those. If I tell you those like 2 sides of 1 inch, 2 sides of 3 inch, and not a rectangle, make sure that you can think of like, oh, well my 1 inch sides could be together, my 3 inch sides could be together. Questions on this, or am I good to move on?
You're good.
I like to show this just because it's a tool that you guys have access to on digits, but it's not something that I make you use because there's a lot of tools that we now have access to. Hey, Thomas. So this tool inside digits.
In this video,
allows
you will
to
learn
draw
about the
these different
building
shapes that
figures
go
mode
down at the
of the
bottom.
2D geometry
It lets
tool.
you do a lot of
Is
different
enabled,
things.
you can
It's
click in
not as nice
to
as the
display
program
its
that I
current
would use.
measurements.
It's similar to it, but it's just not as easy. The program that I would suggest for you to use is GeoGebra. And I think we've talked about this before, but on any of the Chromebooks, all you have to do is search GeoGebra, and it's an app in the Chrome like store or whatever you want to call it. So I just tell it to start, and then I am working in geometry, so I want to create my own geometry. And up here is my menu of everything I want to do. So let's say this next problem wants me to draw the following figure: a square with side lengths of 10 units. What do you think I should click on over here? I'm going to leave that point there. Click where?
Straight lines.
Straight lines? That only gives me lines.
No.
Here's some linear relationships. Ooh. What is a square? It's a type of
Regular.
polygon, right? Any multi-sided shape, which all our shapes are, is a polygon. So, is a square regular?
Yes.
Yeah, so I say regular polygon, and watch what it does. As soon as I drop that down, that's the length of one side. How many vertices is my square going to have? 4. Boom. But now I can grab this and move it. If I want to see how long it is, I come look through my menus again. Ooh, distance or length. If I check the distance on here, well, that's 3.4. If I make that 10, I will have exactly what I was asked to do.
Holy crap. Yeah, it's a big,
There's my square. I don't need that. I don't need that. So, done. Modeled it. So those of you that have worked in Blender, this probably looks really, really simple to you. For those of you that have never done any kind of modeling like this, I think we're going to take a day later in the week to just play with GeoGebra. I want to see if there's like any lessons already made or what I can make. But it's like, if you are just bored during AOR extensions, come in here and play with this. It's really fun. You can start making like really insane shapes or putting shapes inside of other ones. Because now, if I, check out what else I can do, just to show you how cool this is. Let's do a segment from here to here, a segment from here to here. I'm going to drop a point where they intersect. So a point at an intersect. So now I'm going to do a circle with center through this point. And I'm going to make the radius the size of the circle. But now I could work by saying, okay, I want to know the area of that circle. So let's say area of this circle. Well, there's the area of it. I can do the area of the square. And without, I'll play in this way too long if we keep going. But then we can look at the relationship of the area of the circle versus the area of the square, all that sort of stuff. What will the area of this square be if the side lengths are 10? 100, right? So what we can see is the area of the circle is 78.56 compared to 100. We can work the formulas like we did last chapter to see how much space is left over up here. I could also then, remember that problem with the t-shirt printing? Do you remember what I'm talking about? So if I want to make this look like that, I can now tell it I want a midpoint. So it will find my perfect midpoint, boom. This will find my perfect midpoint, boom. Perfect midpoint, perfect midpoint. I've got a couple things in the way. I can move these if I want, the length and the distance. So then I could do a segment from here to here. From here to here. I can then draw more circles by finding midpoints of here. That midpoint will be the very center. So if I do another circle with center through this point out to this edge, I can now like model that situation. I can just keep going, and it gets really, really insane. So I may put up a challenge to you guys to like build this shape, then inside of it put that shape, then inside of it put that shape, then calculate. Like then if I want to look at what would happen if I did a triangle inside of here, well, let's do a regular polygon. But now I'm going to use, no, I can't make it regular polygon. Let's just say polygon here. So now I've got a triangle modeled inside my square with the circle. And I can just keep going. Yeah, right. Alright, so I would suggest using GeoGebra if you want to model any shapes. Yes, Pearson has their model. So let's try this. A rhombus with side lengths 4 units, an angle measure of 40 degrees, 140, 40, and 140. Notice if it's a rhombus, we're going to have those two pairs of parallel sides. By the way, if you're ever confused by any of this stuff, that is vocabulary. So if you're ever working in digits, anything that's blue is hyperlinked. You can jump to the vocabulary definition. Parallelogram, side lengths are all the same lengths. So that's where a rhombus is like a square. That's why a square is a rhombus. Because to be a rhombus, you have to have all side lengths be the same. I think we mislabeled something earlier in the lesson. Because it didn't look like it, but again, it depends on how we label it. There's not really anything else to do. So let's look at this. So here's what we have to do, right? Rhombus, 40 degrees, 140, 40, and 140. So how do I model degrees in here? I'm going to start over. Yeah. I'm just going to call it Star Trek because that's what you see. So, what would I click on to do rhombus? How do I want to start?
Regular polygon.
Is it a regular polygon?
Yeah.
No.
Are all the angles on the inside the same? No, and if it's a regular polygon, all those... So we could say polygon, or I could honestly just start... Let's just make a line. Let's just make a line segment. So I'm just going to make a line segment, right? Then I'm going to need another line segment off of that polygon. But I need to make sure that that is how many degrees? 40, right? So now I come up here, and I want angle with given size, or angle it'll tell me either. Well, what if I try angle with given size? What does that mean? Ooh, I can make the angle be whatever I want it to be, but watch, I should not. Yeah, you now owe me a ruler. I now can tell it to make that angle, but it's going to do a new line. So notice it didn't go where I wanted it to, so that was maybe the wrong choice. If I come back here and just say, tell me what size the angle is, that's doing my exterior. So I need to try that again and do the interior. So I click my points in the other order. Now I can drag this. Anytime you want to just move things, click on your cursor. So now I can drag this until it is 40. But since that's kind of hard to be perfect with, I can click with my mouse It's still kind of hard to be perfect with. So I'm really going to restart. Start with a point. Or let's do a segment. Segment's fine. Angle with given size on this segment, 40 degrees. Boom, it drops my point where I want it. So now all I have to do is connect it. Now if I want a line parallel to this line, watch how easy this is. I could just try to drop a line and like guess and like measure, but that doesn't work very well. Check this out. If I come up into my menus, reflect points, I can drop things. Distance or length, that's not what I want. Parabolas, ellipses, still not what I want. Ooh, lines. Perpendicular lines, parallel lines. So see how in this menu I can draw a parallel line. Look at what it tells you to do. Select a point and parallel line. Okay, well I need it to go through this point and be parallel to this line. It drops the parallel line. I can do that again. Parallel line. It tells me at the bottom, select a point and then a line. So I need the next one to go through this point and through this line, or parallel to that line. I can drop my last point, but I want to click intersect because it's going to be the intersect of these two. And now I'm done. And then I can tell it to give me all my other angle sizes. So what's the size of this angle? 140. What's the size of this angle? 140. What's the size of this angle? It's 40. Because opposite angles have to be equal. Then I could tell it to give me the length of these. So distance or length. What's the length of this? 3.92. What's the length of that? 3.92. To be a rhombus, they have to be exactly the same. So notice they are exactly the same.
I have to make it so that's 4 though.
Well, no, did it tell me side lengths? Length of 4 units, yeah. So now I need to move one of these. Watch how if I move it, everything moves. Because it's all connected to each other. Now, if I drew this on my own and I did not use those parallel line tools, this would not all move together. I'd have to move each point individually. So that's why we want to use those rules to model this. Because now if I stretch this until it's 4, now is when my click is sometimes useful. Maybe. Boom. There we go. Rhombus, side length 4 units, 140, 40, done. Yeah?
Could you get rid of those extra lines, like on the outside?
To do that, I would want to just put lines on top of these and then like get rid of the other ones. So I could do another segment from here to here, another segment from here to here, and then I could actually, ooh, nope. Yeah, I think we might want to leave. I was able to do it back in college. I figured out how to, but I haven't done enough GeoGebra work recently. So maybe that's one of those things that you guys might actually figure out. But even if we have the extra lines, that's okay because the shape we're looking at is just this right here. The extra lines are okay. Any other questions? We're going to do a lot of this week. We're not going to try to move super fast, so I want to make sure that we understand all this. We cool?
When are we gonna do the math thing?
The what? Me checking your stuff. I figure on the day that we do this modeling, where you guys are working on your computers, I'll just come around and check it then. Because we'll just be working on Chromebooks.
Chromebooks are awesome.
That's really all I have for you guys. We have a couple minutes left though, so I guess we'll just hang out.
Okay.